Hi everyone, Professor Sebastian again. Welcome back to our statistics class notes. We're in section 6.2 talking about the normal distribution, and we're at the bottom of page 82. Actually going to go over some examples of how to find probabilities using the normal distribution. Okay, so the normal model, n of 64, 3, so remember the first number here is the mean of the distribution we're looking at, and the standard deviation is the next number, 3. That gives a good approximation of adult women's heights in inches in the United States. Find the probability that a randomly selected adult woman from the US is between 62 and 67 inches tall. So always make a sketch first. Remember that before you actually go to StatCrunch to figure this out. So I'm making a sketch of a normal model that has a mean of 64 and a standard deviation of 3, right? That's n of 64, 3. So you just draw a bell curve. You don't have to be an artist. Do the best you can. Remember, the middle of it is your mean. So there's 64. Now it has a standard deviation of 3, so I'm going to make 1, 2, 3 tick marks, and each one of them is 3 longer. So 64 to 67, that's 1 standard deviation. 67 to 70, that's 2 standard deviations away, 70 is. And 3 standard deviations away now is 73. And the same thing on the other side. And then I'm going to shade in the area of the probability that I'm actually trying to find. So we want the probability that x, the height of a woman that we pick randomly out of a population, is between 62 inches and 67 inches. So since it fits the normal distribution, it's talking about this area under the normal distribution curve. Now we can't do that by hand at all, so we have to go to StatCrunch. So I'll walk you through on StatCrunch how to do that at the same time as you can look at those directions. So in StatCrunch, we want to be in StatCrunch, and we're going to Stat, Calculators, Normal. So we want to find normal about 2/3 of the way down. There's normal. Okay, bring that over here so you can see it. Okay, now you need to put in the mean and the standard deviation of the normal distribution we're looking at. So the mean we're looking at is a 64, and the standard deviation is 3. And we want to, notice I don't have a way to put anything on the other side of x here. So I have to go up and I have to click this between button. And now I can put things on both sides of x. So I want x to be between 62 and 67. So I'm putting those both in. And when I hit compute, the probability will show up right in this box. So I'm going to hit compute. There we go. So that probability is 0.58885221. And I cut and pasted that same thing right into your notes that we just saw, and there it is. Okay, that's the probability that x. So if I randomly pick a woman out of the population, the probability that her height is between 62 and 67 inches is about 58.9%. As another example, let's say that research has shown that the distribution of newborn Pacific Harbor seals' birth lengths is approximately normal, with a mean of 29.5 inches and a standard deviation of 2.5 inches. Find the probability that a randomly selected harbor seal pup is longer than 31 inches, I should have said there. So first of all, I draw a quick sketch of a standard bell curve here, and then I want to look at the normal distribution with a mean of 29.5, standard deviation of 2.5. So right in the middle is 29.5. So if I go 1, 2, 3 tick marks, each one of those is 2.5 away. So 2.5 is 32. Another 2.5 is 34.5. Another 2.5 is 37. Subtract 2.5 is 27. Subtract 2.5 is 24.5. And subtract another 2.5 is 22. So that covers 99.7. Remember, from 3 standard deviations below to 3 standard deviations above goes 99.7%. Now, that doesn't really matter in this example. In this example, we're looking at, we want to know what's the probability that a randomly selected harbor seal pup is longer than 31 inches. So 31 inches is about right here. So we want the area underneath the normal distribution where x is more than 31. So again, now we can go to our, so there's the result, but let me go to StatCrunch and show you. So I'm going to go ahead and edit this, except now I got to change my mean to 29.5. And my standard deviation is 2.5. And now I don't want x between two numbers. I want it greater than something. So I'm going to go standard. Okay, so I want x to be greater than. It doesn't matter about greater than or equal to or just greater than, so it's always going to be greater than or equal to because the area under any one point for the curve is 0, so don't worry For a continuous distribution, you don't have to be that careful about greater than or equal to or greater than, etc. Now we want it to be greater than 31. Hit compute. That's very similar to the picture we drew, and we can see then that the probability that a randomly selected seal harbor seal pup, selected from the population of harbor seals, to be greater than 31 inches is about 0.27425,312. And that's exactly what I cut pasted into your notes right here. So it's about a 27.4% chance. And here I just want to remind you that the normal model and the empirical rule, so we actually got the empirical rule from this normal model, and you didn't really realize it at the time. I might have mentioned it, but the bottom line is we know that about 68% of the data falls within 1 standard deviation of the mean, about 95% of the data falls within 2 standard deviations of the mean, and about 99.7% of the data falls within 3 standard deviations of the mean. So this 1, 2, and 3 are not exactly correct, and you'll see that a little bit later on for the actual normal distribution, but it's so close to those that we just use those numbers. Now the one I'm showing here is the normal distribution with a mean of 0 and a standard deviation of 1. And hopefully you recognize that that is the z-scores. We actually had a question on the first exam about this, that the mean of the z-scores is 0 and the standard deviation is 1. So this is called the standard normal distribution. Okay, and when you know the empirical rule, as long as the range of values you're trying to find up shows exactly on standard deviation lines, then we can actually find areas without using technology by using the empirical model, and I'll show that in the next video.